Okay, we need dy dx. Let's implicitly derive both sides with respect to x. The product rule here, because this and this are two distinct functions. So the derivative of y with respect to x, we write that as y prime. And then we keep the second function the same. Plus the original first function times the derivative of the second function. Now this needs chain rule because the derivative of the outermost function is cosine. And the derivative of the innermost function, that's kind of tough. You might want to write that one off to the side because that again needs the product rule. The derivative is going to be the derivative of the first term times the second term kept the same, plus the original first term times the derivative of the second term with respect to x. So when we're valuing the product rule, we got this for the derivative of f times g plus f times the derivative of g is what we're still working on over here. We just found out the derivative of the innermost function is y plus x y prime. We needed the chain rule there. Okay, so there. The derivative of this is all this stuff. And still using implicit differentiation, the 2 comes down and multiplies, but then because of the chain rule, we need to multiply by y prime, and the derivative of 8 is nothing. Okay, so our next goal with implicit differentiation is algebra, and the goal is to get the y primes all on one side. So I'm going to distribute this to everything inside the parentheses, keep everything else the same. So y cosine xy times y makes y squared cosine xy. And then multiply this times this, we get x, y, and there's a y prime cosine x, y. That equals 2 times y prime. Okay, so we distributed. Now let's collect all the y prime terms on one side. So I'll subtract both these and put them on the right side, but you could do it a different way algebraically. So that's going to be 2y prime minus the y prime sine of xy minus the xy. Did we get a y squared somewhere? Yeah, it's over here. Okay. Sine of, so we subtracted this from both sides. Xy, y prime, cosine xy. I mean, the problems in this book are way harder than the problem I did when I first studied calculus. So sometimes I laugh just because the algebra is so crazy on some of these problems. This one's not too bad, but what did I wrote equals? What was it doing? I don't need that. I was just dozing off. That shouldn't have been there. Okay, we just move those terms to both sides because now we can factor out a y prime from both sides. So y prime gets factored out, and in parentheses you're left with 2y minus sine x y minus x y cosine x y. And then we want to just divide this from both sides to finish getting y prime by itself. So let me see if I can do some lazy stuff here. So we're dividing that from both sides. So that's going to be the denominator. This is going to be the numerator. Okay, I think I got it. The only other question would be if there's some crazy algebra trick we could use to make this cleaner, but I don't think so. I don't see any terms we can factor out from the denominator. Yeah, I think this is it.